Objects can sometimes stick and move together following a collision. Let's look at a simple way of demonstrating this. Here we have two people on roller skates. One is moving towards the other. They collide and both continue moving afterwards. Now let's suppose they join together somehow, maybe because they've grabbed hold of each other, or the second person is constantly pushing the other instead of the collision being brief. We see that they move together. Most importantly, if we look at their motion, we see that they have the same velocity, which is what lets them move as one. If we were to analyse what's happening here in more detail, how exactly should we treat the two skaters when they're joined together like this? In particular, when thinking about their momentum. Well, the objects can be thought of as a single object. Let's go through our example again. This time we'll label the momentum of the first person as P1. Remember that momentum is the product of mass and velocity, so as this person is moving, they must have some momentum. Let's also make this example a little bit more complicated by having the second person moving towards the first. This means they'll also have some momentum, which we'll call P2. Remember that momentum is a vector, so the fact that these two momenta are in opposite directions is going to be important. So as before, the two people collide and then they will move as one. Now we could consider them as two different objects with two different masses moving at the same speed. That means they'll have two different momenta. But it makes life a lot easier if we consider them as one object, with a mass equal to the combination of their individual masses. This means that as they move, we only need one momentum to describe this movement. But what would this momentum be? Well, the momentum of the object will be the same as the total momentum before the collision. Remember that the total momentum in a closed system is conserved. The total momentum before a collision must be the same as the total momentum after. Let's apply that to this case. Since the two people are travelling to the right, their momentum would be in this direction. But what would its magnitude be? To figure that out, let's think back to the original momenta. As the two people are travelling in opposite directions, the total momentum would be the difference between their individual momenta. Then, since after the collision we say that there is only one object, its momentum must be equal to this total. That total is P1 minus P2. Only having to write this is a lot simpler than figuring out how this total divides between the two people. Now let's look at another example, but this time where the two momenta are equal and opposite. If two objects collide head-on with the same momentum, then they can both be brought to a stop. Here we have two cars driving towards each other. The first has a momentum of P, and the other has equal and opposite momentum P. The cars collide and stick together, but this time there's no motion afterwards. The collision causes both cars to stop. Let's think about why this is by looking at the total momentum before the collision. The two initial momenta were equal and opposite, so the total momentum was 0. This means that after the collision, the total momentum must also be 0. In this case, the momenta of both cars cancelled each other out. Now it's also possible for objects to conserve momentum, in this case by bouncing off each other, and still have equal and opposite momentum. In your exam, you don't need to be able to predict if and when objects stick or bounce after a collision. What's more important is being able to explain why and how momentum is conserved.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!